Hi everyone, myself Srini, and I'm with Neil, uh, and we are with Qualcomm Landing Team. What we're going to do today is just give a traditional upstream status, BoF. It's going to be very interactive. I mean, I'm going to pass the mic to the particular expert, and he can brief. They can brief on what's happening, and what they are working on, or what's the future plan, and what are the issues, things like that. Um, so the agenda is pretty simple. We'll touch base on different topics around the kernel upstreaming and different subsystems, and we'll see what are the interesting areas where we made good progress, and what are the new SoCs what we added support to, and also touch base on how many patches have been going around in the MSM mailing list, and how the support has been improving in general. So this is just a snapshot of the MSM mailing list, and the blue line is representing the number of mails, and the red line is the patches. There you can notice that there's a spike somewhere near about start of in January sometime. So the reason for this is because Qualcomm normally tends to announce new SoCs somewhere near to the end of the year, and then we work on it, and we see a right time to come, and then maybe the RC1 has been released at that time. That's when we send lots of patches. That's why you see the spikes there. But it's pretty, we can see the amount of patches are significantly increasing since we started in 2018. And these are similar metrics from the DT boards itself, the number of boards that's been added across different releases. And the cumulative boards is nearly about 300 as of today. If we compare from where we started to how it's going pretty good. I think it's a joint effort by the community, and as well as the focused effort by Qualcomm Landing Team to solve problems and add support there. So in summary, I think the biggest points what we covered in last year or last few months is we added a new compute platform, the Qualcomm flagship Nuvia core-based platform, that's X1 Elite, and it's still not ready for consumer consumption yet, but we still working on adding more support to it. That's something which we wanted to highlight. And the next flagship SoC is the mobile SoC. This is 8650. Neil is the one who actually upstreamed that support. As soon as it's released, the next RC had that support. I mean, the next Linux release had almost boot to UI support. So that was pretty impressive. So when we started way back in 2008 or 2014, at least in Linaro, we were struggling to get boot to shell. I mean, from upstream, we didn't have regulators to, or we didn't have clock support in the upstream. So it was kind of challenge to even get to boot to shell with full upstream. Now we moved from boot to shell to a point where we could actually boot to UI just within a one release cycle. So that's all because of the community support and the contributions coming in from different places. And and we are also able to run GPUs. I mean, we could bring up GPUs early on, even at the bring up stage, and this is pretty impressive. Moving on, we also interesting development. We also added automotive write platform, which is pretty different to other mobile SoCs or computer SoCs. So in this last few months, we managed to actually even add support for this. This is a pretty interesting platform, and it has different capabilities. It's not like a normal mobile platform or a computer platform. The use cases are pretty different. There are many DSPs in there, and it has lots of security features. So if you are interested, you could explore about the platform. Yeah, and then apart from this, there was multiple legacy devices which are being added and by the community and by landing team as well, as they find some hands-on with some laptop or a tablet or any mobile phone. They just go and hack and add support to that. That's pretty impressive. Okay, so do you want to take it?
So we're going to basically show the difference since last Connect, basically, with listing all the stuff that were done in different subsystems. So for the clocks, you see a lot of change, a lot of clock controller added for new stuff and for old and legacy stuff. And there is still a lot of cleanups that were done, mainly by Dimitri, basically, did clean a lot of stuff. A lot of legacy stuff. So, for clocks, what do we need to add?
I think it's pretty good.
Pretty good.
Yeah.
You want to add something on clocks?
Any comments? But so, I think we have a streamlined process of getting new clocks into place.
Clocks is really well defined. It's really easy to add clocks for any clock controller. So we basically only the same bring up. Add the general clock controller, the camera, display, video, audio clocks, and GPU controller. So everything is clearly defined and it's pretty easy to add. Yeah, Conrad did a lot of fix-up and cleanup. Conrad, you want to add something?
Hi.
Thanks for your contribution.
Yeah, I guess there's a lot of yak shaving left, and nobody really wants to do that because it's boring, for one, and for another reason is that you should at least test changes on real hardware, and especially if we're modifying code that also runs on 7-10-year-old platforms, we may have discarded that hardware by now or never had it in the first place, like maybe we've come into the game after it was done by somebody else. And it's really just maintenance in its essence.
Okay. Go to the next one. Power and performance. So basically, it's all the handling of PMIC, but managed by the firmware, because most of the PMIC, we don't access directly the regulator and power domains directly. We pass by a firmware, and we have two different generations of firmware, changed a few years ago, but still all the support architecture is done in pretty good state, so it's easy to add every new and old PMIC that appears. You want to add something on?
Beyond anything interesting that you want to add?
No interesting, all is good.
All is good.
Thanks, Bjorn. On the provider side, so basically we consider the provider side to be all the interconnect, the bus interconnect, the LCC, so yeah, the last level cache controller, all the firmware interface, like RRC and SOC information and PDC. Again, support is pretty stable, so we can add a bunch of stuff quite easily. And it was pretty heavy on this last year. Anything to add on? No. Pin control, same. Basically, no huge architecture change. Basically, like clocks, just add tables and it works. Yeah. Yes. So it includes the LPAS audio stuff, clocks. Yeah. You want to add something?
I think Abel was trying to say is we are in a position where we could even generate the clock descriptions via the hardware descriptions itself and just put it onto our driver. So we simplified the interfaces so that it's easy for get the hardware descriptions directly out of the data sheets and feed it back to the clock controllers. So interconnect and pin control as well. So I think the scripts credits to Qualcomm who invested there. But yeah, it proves that whatever we have is much aligned and in line with what hardware does. So next one. So Jenny is a serial engine again, so it's mostly fixes, not much change there. PMIC, there's some SPMI changes. Do you want to talk about, Abel?
So starting with SM8450, there is a multi-bus support. So you can have, it behaves like two separate controllers basically, but it's not that. You have a single controller and multiple buses, at least two, I think. The X-Elite was the first one where we actually had to implement the multi-bus support because some of the USB repeaters, part of some PMICs, were on the second master. So yes, that's about it.
Okay, thank you.
Yeah, there was some pretty lot of work on the PMIC genning side. So basically, in order to access all the battery and USB-C management firmware, you need to have to access through one of the DSP interface, and it exposes an UCSI implementation, a broken implementation, but still not compliant, with a custom way to expose alt mode, so DisplayPort alt mode. So we spent a lot of time to actually fix it and make it work correctly. So today, I think we have pretty good support for USB-C alt mode support with DP. We still need to figure out how to support the 4-lane support, but it's in the work. And for the IPA side, I don't know if Alex is here. No. Did something?
I mean, we added support for two things, 2 or 3 platforms.
There's very little report. We added support for 2 or 3 platforms, new SoC types, and I think there are a few bug fixes that have gone along the way, and otherwise I'm just doing kind of simple refactoring code. Nothing very major in the last year.
Thanks, Alex.
Yeah, so fast RPC is very interesting topic. This is the backend for doing the AI processing or offloading AI processing onto the DSPs. We have a good upstream support which can run pretty simple use cases and some complicated use cases like TensorFlow and things like that. But there's lots of support missing in upstream, and I think there's the Qualcomm, I think, already is aware of that, and there's a significant effort put on from Qualcomm side. So there's lots of work in progress. It's still not hit the patches state yet. So they're upstreaming their fast RPC lib support, which is not to par with. So the upstream support is not in par with what Qualcomm actually ships. So they are putting effort to actually upstream their fast RPC lib at some point, and maybe in a couple of weeks. And there are some other features like production domain and invoke v2 support, which can do your MD checksum and things like that, and you can get performance numbers out of your invoke request and things like that. So yes, there is a significant in-flight activity, but nothing significantly was added in last couple of months. Only fixes.
When are we going to get proper DRAM axle instead of the fast RPC?
What was it?
What are we going to get? When are we going to get proper DRAM axle driver instead of hacked up fast RPC?
Yes, I think we touched based on this with Qualcomm as well, and I don't think they have any plans to re-architect this. And there's yeah, I think that's a short answer to be honest. Yeah, but we could dig in more details if you want, if you're interested, and we could show what would it bring for them that's something.
API compatibility and modern API.
Yeah, and I think they have. Yeah, we could go on discussing about the benefits of each other, but again, I think they are not in a position to change at this moment in time. They have infrastructures based on this stuff. So,
What about here?
but yes, that's something we could do. Yes. Okay. Audio again. It's my bucket and Christoph's bucket. Christoph, do you want to add something? Okay. So there's been significant changes in audio. We added some new features. For example, the quad speaker support, that means you could drive 4 speakers on your newer laptops. That's been added. Actually, we are working on some of the stuff. The new sets of drivers, machine drivers, and the significant rework of research GPIOs, which are shared across multiple codec chips. This is a very common use case for Qualcomm codecs. So there are multiple speakers and one reset line. How do you manage them? That's a typical problem. And I think Christoph did great work in getting this sorted out. And there were some generic fixes around how to reduce click and pop issues around speakers. Yeah, it's been all merged. And the new sets of codecs which are already merged are WCD939X, which is on SM8650, and there's a WSA884X, which is a smart speaker amp, and that's also merged. We have new LPAS codec support, which is V11. Some of the patches on the list. There's a new codec support, WCD937X. I think this is part of the RB3 Gen 2. This codec will be used, and there's a DisplayPort audio support is also in progress. It's in the list. Some of the work in progress items. As the audio is on the DSP, we need lots of tuning, fine tuning, which is currently missing, and we are in the process of adding that support. Patrick is going to demo some of that thing during Friday. How do you do calibration? How do you real-time tune things? So that's something which we are working in parallel. VI feedback and speaker protection is very critical for compute platforms. We don't want to blow out the speakers. So this is also something we are working in parallel. Soundwire, traditionally it's a PDM port on Qualcomm platforms, but recently they have added PCM port support, which we are working to get support on. ECNS, echo and noise cancellation, that's a module inside the DSP. We have a prototype which works, trying to see how we could get it upstream. And finally, there are issues around Pipewire and Qualcomm audio subsystem. There's lots of, probably it's because of timer-based scheduling, which is disabled on, which is always enabled on Pipewire. So there is some issues related to that which needs to be fixing. Yeah, we are working on those as well. Display. Dimitri?
There is a growth in the platform support. We are starting to migrate some of the older platforms to a newer driver. So if you care, that is, we started migrating platforms from the old MDP5 to the DPU1 driver because well, this is the driver that gets maintained, that gets new features. There was a lot of cleanup. The more important stuff, I would say, it is the DSC 1.2 and fixes for the generic display stream compression support. There were fixes in the DSI support, but they were pretty minor. And DisplayPort got a significant boost, which for some time broke some of the platforms. But fortunately, thanks to Johan and to Abhinav, we were able to find and fix most of the issues. There is an ongoing work done by Qualcomm on fixing the actual hot plug, or reworking DisplayPort driver to properly support hot plug event, which currently works, but as we found during the debugging, it works by chance or by pure luck. So I think that's mostly it.
Yeah, robot rock support. I don't have enough lineage. I typically bring up the 8650 ADSP and CDSP. But yeah, there was many work to support the new platforms, like the X1 Elite, but they're pretty close now. And probably take over the old support for the old platforms. Yeah, nothing.
You want to talk about the DTBs?
Nothing spectacular. The
DTB
DTB.
firmware for the ADSPs?
Yeah, it was. No, it was last year. It was nothing new on this side. So PCIe, many. You want to?
We had a lot of feature additions for PCI. A notable one was we enabled the power saving feature, ASPM by default, for the newer SoCs. And then we are also trying to simulate hot plug. So because we don't have the native hot plug support in most of the Qualcomm SoCs because of form factor limitations. So we are coming up with ways to simulate hot plug with the existing interrupts and things like that. I think we have an agreement, so patches will be floating around in real soon. So, and we added the, we improved the PCI endpoint support. So PCI endpoint is a kind of new initiative for Qualcomm. So we are trying to use mainline kernel on the endpoint SoCs, mostly targeting the small PCI endpoint, Wi-Fi cards, modems, etc. And for that, we are improving the PCI endpoint subsystem and also the PCI endpoint controller. And we had a lot of work. So we integrated the eDMA support within the endpoint framework to transfer the data faster. And then we also integrated the interconnect bandwidth support so that we can scale it appropriately. And then we are also trying to evaluate the VertIO support for the PCI endpoint, which is hopefully I'll talk more about in the upcoming ELCA. Yeah, that's about it for PCI.
I like the reworked MSI support. That was nice.
Thank you.
Because a lot of chips make the same mistake, but they never fix it, and you just fixed it. Thank you.
Thank you.
What was the mistake and what did they fix?
The mistake was directing the MSI into the design where PCIe core rather than directing it into the GIG ITS. Yes. So if it's in the ITS, it's actually fast and it works. And if it's in the PCI host, then there are various bugs and it's slow.
Unfortunately, we cannot use that for all the platforms, the legacy platforms, but at least for the newer ones, we are trying, going with the ITS.
Right, so if you have an ITS, then it's great if you can use it.
And in ITS, you can migrate the IRQ on all platforms. IRQ and distribute interrupts on all CPUs, which is the main feature.
Well, I think it was interesting that the reason for having the ITS support for Qualcomm SoCs was that Lenovo asked us, when we compare the NVMe IRQs of x86 machines, we can see that the interrupts are spread all over the 8 cores, but for Qualcomm it's just 1 core. Yeah. And then so we added ITS, and now it's spread over all the cores. So, yeah.
So you can only do it for the modem.
And we need to do it for UFS. It's ongoing as well.
Yeah, okay.
So on the PHY side, nothing revolutionary. Not here. So yeah, basically we added support on the existing platforms. We did a lot of cleanup last year to split. We had huge common drivers for all PHYs, which was not really well designed. So we split everything. We have proper PCI Express and combo USB DP stuff, and we added a lot of support for oriented switching for alt mode in the display combo PHY. So we can now support for all the new platforms. We can easily support alt mode on the USB-C.
Okay, just a point to add, or maybe Abel would add it. DP-aux or DP-5. Would you like? Yeah. So basically, what Abel did is to extend the PHY API to be able to say from the DisplayPort controller whether the PHY should be in DP or EDP mode.
I guess that's about it. So there are two components: the display part, PHY part. Yeah, I guess that's pretty much it.
So do you end up as a compatible or a property or what? PHY mode. Okay. Okay. Where is that information coming from? From the DT. Okay.
You can
Elaborate.
how it is specified, because it is not very trivial.
Let's see if I remember. I would probably have to look that up. Yes. So it looks for the aux bus. If the aux bus is there, then we assume it's EDP. And then you you have the set mode, PHY set mode, and then you basically force the PHY to go into the EDP or DP based on that. Right?
Thank you. DT bindings, I think we did, I think Christoph did a lot of cleanup. Very significant. We could see, I wish we could present his graphs, but it's too late anyway, I can't do that. But his presentation clearly shows the amount of warnings that has been fixed on the older platforms, especially on Qualcomm platforms. There have been a steep bottom curve, and that's pretty impressive. Thank you, Christoph, for that. Yeah.
And the tools helps. So for the last 3 platforms we upstreamed, we managed to actually upstream without any warnings. So fully verified DT from the beginning. So it was a huge feature. So on the UFS side, you added the ICE shell block. So on new platforms, the crypto engine in the UFS is no more tied to UFS, but it's shared with SD card controller. Yeah. And the other things, we basically supported GR5 for UFS on the new platforms. And Mani did a lot of work on detection of gear.
I think the most notable feature for UFS is the multi-queue support that we added. I mean, it was Qualcomm who added, and Linux helped review it. Yeah, that was, I think, only Qualcomm and MediaTek chipsets were supporting MCQ in Upstream, I think, right now. Yeah, that was a fair amount of work. And then we also added the Gear 5 support. I think, again, Qualcomm was the only one supporting Gear 5 in mainline right now. And MediaTek also jumped in. Yeah, and then we added the OPP integration with the UFS framework, thanks to Christopher starting that work. So that allowed us to scale the both interconnects and also the RPMH based on the gear and then lane speed. Yeah, that's about it.
So I think it's simple thing here. We added lots of new firmwares, which ended up into Linux firmware. Sorry, I mean, like there's.
I think you can guess what I'm going to say about the firmware. Please do not put file names into the device tree. Do not load firmware files by file name from a device tree property. This is wrong. Don't do it again.
Unfortunately, we have to do this because firmware for the.
No, you don't.
We can discuss it afterwards.
Yes, I mean we've discussed it many times.
Sorry, I'm not caught up on this. On production devices with signed firmware, which is built specific to the device, we
cannot get the how to get
I previously proposed that we use device tree compatibles for the machine to build the path. Would that be something you'd prefer? Yeah?
We do it for some Bluetooth and Wi-Fi stuff.
Yes.
The Qualcomm Wi-Fi.
So
Add try the first path and add the compatible of the board and from the stuff.
I just want to add one more thing. So the audio does exactly what Arn asked. So it generates the path and file name automatically by knowing that what kind of platform it's working on. So that works fine, I think. Yeah.
So the issue is the firmware that we have across different production devices, it's 99.9% the same. Maybe a vendor changed like 3 lines of code within it, but the signature is what matters. And if we weren't to specify it, the path to this specific file, we would need to like walk the entire firmware tree and compare the hashes, which is besides the point.
No, we would use the root device tree compatible to build the path for the specific device.
We do it on all PCs.
Okay, so I think we are running out of time. So yeah. So next slide. So this is a list of platforms. This is probably more than there'll be more than what we actually listed here. So it's pretty impressive. I think thanks everyone for the work. We look forward for more contribution. Yeah. Wanna go? Sorry.
So great job on getting all this hardware up there. Could you maybe outline how you're testing the hardware? I think somebody mentioned like it's really important to test on hardware so we don't break.
Okay, that's something which we are still working on, and we have some infrastructure in place to do that, but it's not formally done as a process. So we do test. Personally, like Dimitri has his own lab, Neil has his own lab, Bjorn has his own lab, but we don't have a formal Qualcomm lab. I think that's something which is cooking. I guess you are aware of that. And similarly, on landing team side, we are also trying to come up with some CI style thing which could test automatically by Linux Next or and be more formal. Yeah.
Which is not going. It is not going to be. It is already.
Yeah, it is. It is already. I mean, it's already as chunks of pieces of work, but not.
It's working.
It's a prototype, so.
Yes, it is a prototype. Yeah.
As it is working, a prototype.
Yes. Yeah, that's what I said. We are evolving. Yeah. Okay, so next slide. Okay, so this heat map is something Dimitri put on just to show what SoCs are supported and what IP blocks in that SoCs are actually upstream. Probably it's not very visible for you, but I can provide you the links right at the end, so you guys can have a look. Yeah, you want to go down? Yeah. Yes, it's pretty blurry. Okay, yeah, next one. Yeah, I think this is all it is.
So the point is to find out which areas are missing, basically, and which the difference in feature in all platforms, basically. And we see all the multimedia features here on newer platforms are missing, basically. But all the common support is okay and common to all SoCs. So it's pretty cool thing to have. This is a PMIC support, which is, I think we lack a lot of data, basically. So.
It is not available, which means it is not available in the hardware.
Yeah, I'm not sure because most of some features are available, we don't support them or.
When I was feeling M8, I was going through the images. So M8 is not
Oh.
available.
Okay.
Yeah. As you already know, there's a mailing list, Linux ARM MSM, where we CC all the patches related to Qualcomm. You could subscribe to there and review patches, and if you need help in booting an upstream kernel, there's a blog as well, which put in, and we have the drivers upstream status in a GitHub link. Yeah, it's pretty straightforward, I guess, but yeah. And the presentation is actually running on X13S. Sorry, I didn't mention that before.
Also missing from here is github.com/Linux-MSM. There's all of the tools that are still necessary for remote procs and some CI configuration and things like that.
And debugging. Yep.
Just from my side, as your upstream, I have to say I'm absolutely happy with what you've done over the past year. Every single release, the stuff that I got from this team has been at least as big as everything else combined for all the other SoCs, which is an amazing amount of code and very high quality. I'm absolutely happy with that. There's one SoC family where we have more supported boards because IMX has been around for longer and they have constantly done work over many years, so they have more. And we have a couple of SoCs that are a little quicker getting things upstream before the announcement, but everything else, like you're doing such an amazing job. Thank you.
Yeah, I think it's a nice way to end the presentation. Thank you, Arne, for the appreciation. Everyone who contributed deserves that. I think, thank you. And Bjorn as well for taking our patches. We look forward for more support.
Say no to the patches.
Okay, yeah, good. Thank you. I think we're done, isn't it?